Okay, so 11.5. We're learning about inscribed angles and polygons. So today's objective was to use properties of inscribed angles. We have the definition of an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. See it right here. And then whose sides are chords in the circle. We know that chords have the two endpoints on the circle. Our next one was the intercepted arc. This of the angle is the arc that lies on the interior of the inscribed angle and has endpoints on the circle. And you see it here. So you saw that the arc has the measure of 220, which meant the angle is half of that, which is 110. We followed on to our next definition, which was this formula. You saw that if an angle is inscribed in a circle, then the measure is half of the intercepted arc, if I could say it. And you see over here that you have that formula. The measure equals 1/2 the measure of AB, which is that arc. That should be an arc picture right here. That, not a little square. Okay? So you see that 220, to get the intercepted angle, you have to do half of it, or the inscribed angle. And then we had these problems, which you guys just completed. And you guys already told me the answers, so let's go back through them really quick. So this one, you have the angle on the inside, so we multiply it by 2, and you get the outside, which gave you what? 100. Over here, we talked about how this was the central angle. The central angle is 120, which meant that this whole arc here also has to be 120. So then we have to do half of that, which gives us x equals 60. And then our last one, which is the one we just did, and Mario told us the answer. You multiply by 2 and you get what? 230. And all of this is based on that last formula. So if you're going from angle to arc, you multiply by 2. If you're going from arc to angle, you divide by 2. Okay, and this is where we left off. So you now have inscribed and circumscribed. So if all the vertices of the polygon lie on the circle, the polygon is inscribed in the circle. And the circle is circumscribed about the polygon. The polygon is inscribed in the polygon, or the polygon is inscribed in the polygon, and the circle is circumscribed the circle. So circumscribed goes with circle, inscribed goes with the polygon. We have these two theorems. The first theorem is if a triangle is inscribed in a circle and is a right triangle, then the hypotenuse is the diameter. Remember, the hypotenuse is the side directly across from that right angle. The opposite of this is if a side of a triangle inscribed in a circle is the diameter, then the triangle is a right triangle. So right here we see that we have a circle, a triangle is inscribed in it, and one of the sides is the diameter. That means this triangle has to be a
180 degree angle.
Some has to be that, but it also has to be a, last slide, had to be a right triangle with a 90-degree angle. We know the 90-degree angle goes across from the hypotenuse, which means that y has to be 90 degrees.
Wait, that's not right though.
You can do the 180 minus 90 minus 60.
60, 90. Right.
You have a circle. In the circle, you have a triangle that's inscribed. In this, you have the longest side being the diameter, which means this is what type of triangle?
45, 45, 90.
It is going to be a 45, 45, 90 because it's going to be a right triangle. So we know right here that x has to be 90 because it's right across from the hypotenuse. And y has to be 45 because that's a special right triangle, but you could have also found it by 180 minus 90 minus 45, which gives you 45. And our last one right here, once again, you see you have a triangle that's inscribed in a circle. You have a side that's the diameter. That means it's a right triangle, which means y has to be 90. Ooh, I almost wrote x. And that means x equals 180 minus 90 minus 32, which is?
Could you do 90 plus 32 minus 180? What?
You would, but it'd be a negative answer as long as you try to positive. That's fine. Yep. It's fine to do it that way. So what is 90 minus 32?
That's like...
Most of you have calculators at your seat.
That's like 50... No. It is like 50 something.
58. So x equals 58 degrees. Okay, so we have a quadrilateral. So if a quadrilateral can be inscribed in a circle, the opposite angles are supplementary. What does it mean to be supplementary?
180.
Adds to 180. The opposite of this is if the angles are opposite of each other in a quadrilateral and they're supplementary, then it can be inscribed in a circle. So if the opposite angles are supplementary, we can make it in a circle. We can inscribe it. And if it is inscribed, then we know the opposite angles are supplementary. Okay, so we see we have a polynomial, a quadrilateral inscribed in a circle. And what happens with opposite angles? When they're not congruent, they're supplementary. So that means they're adding up to 180. So we take 180 and we subtract 92 and we get our other angle. So x equals 180 minus 92, which gives me what value did you just tell me? 88 degrees. Our other one is we have y, which is 180 minus our 60 degrees, which gives me? Okay, our next one up over here, we have x. Hold on, ladies. So we have x equals 180 minus 110, which gives you 70 degrees. We have y, which is 180 minus 85, which is 95 degrees. And last but not least, we have x, which is 180 minus 97, which is?
What'd you say? 83.
83 degrees. And we have y, which is 180 minus 79, which is? It's not going to be 99.
99, I'm sure. It's 101.
101 degrees.